All right, question 3. Here we've got a picture and then a story. Marama is snow skiing and uses the ski toe to get to the top of the slope. The ski toe pulls Marama up the slope to a height of 46.2 meters, and the combined mass of Marama and her ski gear is 62 kilos. Calculate the work done for Marama to reach the top of the slope. All right, so we're talking here about vertical work because we've only got vertical distance here. So we know that work is equal to force times distance, and we have distance is equal to 46.2. Now what else we have is mass, which is equal to 62 kilos, but we're looking for force. So the force that we're talking about here is downwards force, and downwards force is weight force, so weight force. And weight force and force is equal to mass times acceleration, but the acceleration we're talking about when we've got downward force is g, so that's acceleration due to gravity. So we can figure out what her weight force is by going 62 times what g is, which is 10, and that is in the information at the front, and so 620 newtons. So now we've got force is equal to 620 newtons. All right. So we can now put this into the calculations. The work that is being done here is 620 newtons being pulled up over 46.2 meters. And so 620 times 46.2 is equal to 28,644, 28,644. And if you remember what work is measured in joules. So that is joules. Now this question actually works with the next part of the question as well. So I'll tell you the full marking when I do the next part as well. So B, it takes 525 seconds for the toe to pull Marama up the slope. Calculate the power needed to get her to the top. So ignore friction for this. Okay, so we're actually needing to use the work. So we know that it requires 28,644 joules to go up. How much power do we need? So power is work divided by time. So we have the work 28,644, and we're dividing it by the time in seconds, 525 seconds. So divided by 525 gives us 54 points. Well, let's round it. You can write 5.6 or 0.6. And power is in watts. So watts is required. Okay, so these two, to get both of these correct, that will give you the excellence for both of them correct. But if you correctly calculate work, so work up here, that would be a merit mark. And if you then, or if you do make an error there and calculate power correctly, but you've made an error in your work calculation, you should get the merit of that as well. But both of them to correct together give you the excellence mark. Obviously, there's achieve marks there too in calculating your weight force. So if you do that correct, that will give you an achieve. So make sure that you know what you're doing there. If you didn't correct your weight force correctly and then went on to calculate your work and then went on to calculate your power, that's where you'd kind of get the merit for. You wouldn't get the full excellence for. All right.